For centuries, mathematicians have tried to square the circle by constructing a square with an equal area to a given circle. The circle is a unique shape because it has something no other shape has, the irrational number pi.
What makes you unique?
My friends would say that I'm always hopelessly optimistic.
My hobbies, my interests.
I enjoy playing sports. I play field hockey and lacrosse. I also like chemistry.
My friends say I'm very talkative and I can get along with just about anybody.
My fingerprints, my DNA structure.
I'm outspoken, I think for myself. I live life to the fullest, I'm athletic, and I just like to work hard.
I'm my own person. I act the way that I really act around everybody else. I don't try to lie to people and make them believe that I'm something that I'm not, just so they can be my friend.
The circle has been called the perfect form. It is the locus of points equidistant from a given point, known as the center. It is the shape of the sun, the moon, and many things we hold dear. In fact, an analysis of circles gives rise to one of the most well-known numbers, pi. Take a circle and measure its circumference and its diameter. Then divide the length of the circumference by the diameter. This ratio equals pi, and this is true of any circle. Pi is an irrational number, meaning that it cannot be written as a terminating or repeating decimal, or in the form a over b, for two integers a and b. In fact, pi has proven to be the most irrational number of all because countless mathematicians and other enthusiasts have tried to prove that pi is, in fact, more like a rational number. This irrational practice is also known as trying to square the circle. For centuries, humans have tried to make rational sense of this irrational form in the form of squaring the circle, creating a square that is equal in area to a circle. The goal is to do so with a geometric construction. The ancient Greek dramatist Aristophanes once said, "With a straight ruler I set to work to make the circle four-cornered." Squaring the circle proved to be an impossible task, but looking at efforts to do so can give us insight into the mathematics of pi. The goal of constructing a square and circle of equal area implies the area of a circle is of the form s squared for some value s, which is true of all squares. In fact, with many squares, the value of s is a rational number. For example, a square of area 4 has a value for s of 2, a square that can easily be created as a geometric construction. So, the first mathematicians who tried to square the circle would have assumed that pi, which is related to s, was a rational number. It wasn't until the 18th century that a German mathematician, Johann Lambert, proved that pi is, in fact, an irrational number. This didn't necessarily mean that the circle couldn't be squared, it just meant that the value of s would have been an irrational number. For example, a square with a diagonal of length 2 has a value for s of square root of 2, which is an irrational number. So, even though pi was irrational, it might still be possible to square the circle. The final blow came in the 19th century when German mathematician Ferdinand von Lindemann proved that pi was also a transcendental number, a special type of number that could not be written as the root of a polynomial equation. In other words, pi can't be written as a number like the square root of 2. By contrast, another famous number, phi, also known as the golden ratio, is irrational, but not a transcendental number and has two values, 1 plus the square root of 5 over 2 and 1 minus the square root of 5 over 2. Pi cannot be written in a form like this. As a result, there is no geometric construction that will allow a square to be constructed equal in area to a given circle. Squaring the circle was impossible. There is a saying that what makes something unique makes it truly beautiful and interesting. Could it be that the uniqueness of pi within its circle compelled centuries of scientists and mathematicians to try to conquer its structure by squaring it, until finally proving that it was not possible? We are constantly reminded of the circle's presence and uniqueness. Perhaps it's the circle's way of holding us captive. Did you know? The first known reference to squaring the circle occurred in an ancient text that dates to about 1850 BC. It claims that the rule for squaring the circle is to cut 1/9 off the circle's diameter and construct a square on the remainder.